Okay guys, welcome back to working through your IA2. Obviously you've got your IA2 page open here and you are hopefully getting through it, and at this stage you've got down to your tables and graphs. So you've got your table. Remember, I've shown you in the last video how to do the standard deviation, the average and the standard error. And for the graphs, the standard error could help you put some little error bars on your results. So if you work out it's plus or minus 1 or whatever, then that's okay. Another thing they do in the actual standard, the QCAA provided one, is they show you here that confidence interval is another thing you can do. So the average is obvious, you know, add them all up and you get the average result. Standard deviation is how much your results, your data is spread around your average, what the spread of it is. Standard error is the error due to normal circumstances, so plus or minus whatever. Confidence interval is a bit different. It's not the same as the range. So on the site, so I've got a confidence interval calculator. So I put in an example. Say for example, I was looking at pH, and I looked at 12 bits of data. So I went across here and got 12 bits of data. You need your standard deviation. Yep. You need to get your confidence interval, you need your standard deviation, and you need the number of scores in your sample. So you've already got that from your table. So I just did it for the example one. So I had 12 bits of data. The mean of the pH was 6.5. The standard deviation was 0.9. I pumped them in, and it says that the confidence interval is 6.5 plus or minus 0.509. That means with 95% confidence, the average falls within those two numbers there, 6.5 minus 0.509. It's not the range of the data, it's how confident you are in your average. So sometimes you actually do little little confidence interval bars, but that's not necessary. You're just going to put your error ones probably in your graph. Well, it's important because it's not the range. For example, say I've got 5 bits of data here. The range would be smallest up to the biggest, what range you've got there. Yep. Confidence interval is how confident you are that your average is correct. Now, the more number of data you got, the more confident you are in your results. So if I've only got 5 bits of data, I've got a really big confidence interval. I'm not really confident at all that the average is correct for that small amount of numbers. The more you get, the more confident you are that your average is correct. Yep. So it's not the range, not like the standard deviation, which is sort of like the spread. It is a 95% chance that you got the true average or the true mean. Yep. So you can put that into your data and look at the example one of how they use that. You probably put your error bars in your actual data, but if you're looking at overall percentages and things like that, you put your confidence interval. So here they're comparing the percentage of change in their number for these two particular things, and they're more confident in this one than they are in that one, obviously. So you can look at confidence interval in your results. So what are you doing with your interpretation? You're interpreting the data that you've got. So you've got tables, you've got graphs. Now you've got to interpret it and analyze what it means. Yep, that's the next section of your write-up. So in your template, you'll be going to this part here. So you've got all your graphs, your tables, and your averages, calculations, standard deviation, etc., and your confidence interval. And now you're going to talk about the trends, patterns, or relationships. So what's the overall relationship between your two abiotic factors, whatever they are, and your two abiotic factors, and the standard, the biodiversity of your area, or the dominant type plant that's there. Is there a relationship between, if you chose pH and nitrogen, is there a relationship or a trend in the graph or in the results that shows there's a relationship between them? So you want to talk about that. And the example of types of things you might put in is that the pH average in the say for in the ecosystem that's got the open sclerophyll forest, the pH average in there is 6.2, whereas the pH average in the paperbark Melaleuca swamp forest might be 7. I don't know what it is, doesn't matter. So you're saying that it's greater, the pH is a higher number, so it's more than in one than the other, or it's less in one than the other, or they're the same. Yep, so these are sort of the words you could use, and that's in this document here, types of words you could use. So if you go into that one there, it tells you exactly what you need to put in to, and same with this other one. This one here tells you what to put into each section. So now we're sort of doing the analysis and the conclusion. That's what we're sort of doing. So I clicked into this one here. If you scroll down to where you come out up to this analysis and conclusion, it tells you how many words there should be, so 400. Yep. I'll go back to this one. And in here it says analysis of the data. Yep. Thoroughly identify the trends or patterns. Make sure that you say whether it's a strong trend, a weak trend, an obvious trend, it's not obvious, or there is no trend, things like that. And then you've got to talk about the limitations or uncertainty and limitations of your evidence. That's the data only. We're only talking about the data here in this part. So if you actually go to the sample one, we're talking about the data. Yep. So what are the errors or limitations of the data? So it might be a high error rate. It might be you haven't got a lot of data size. You haven't got a large number of samples in your size. It might mean that the range is really great. Standard deviation is pretty large, so it's not really that accurate. Yep. But you're interpreting what the actual results say. So first of all, identify the trend, and then analyze the uncertainty and limitations of that evidence. So I did it for this one as well. Interpreted the trend, and then analyze the limitations or uncertainty of that trend. So here they're talking about confidence interval. They're not as confident in one than the other, but because they don't sort of overlap, they're probably pretty accurate. They can use them as a result. So that's data. You're talking about the data, and that would be included in this errors of the data. Yep. Then you've got to interpret the evidence to draw a conclusion. So once you've done your 2 interpretations or 3 interpretations, you have to come up with a concluding statement. Now you can either put it here, or quite often they put it at the end. So there's a conclusion there that summarizes the results. Make sure you put a little bit of evidence in that conclusion. Yep. So what it means, in other words, this is the result you got. Here's some of the percentages or changes you got, and this is what it actually means, the importance of that result. Yep. So you got to justify the conclusions, comparing your experiment to the original experiment. Are you confident that your result showed a good indication of what was different between the 2 environments? So that's your interpretation of your data and your conclusion. Cheers.